And they may well ask, why climb the highest mountain? Why 35 years ago fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon.
We choose to go to the moon. When JFK spoke those famous words in September 1962, he had no idea what he was getting his country into. No one did, really. At this point in the timeline, NASA had successfully put one chimpanzee into orbit in November 1961, and by February 1962, they had launched astronaut John Glenn on a 3-orbit spaceflight, making him the first American human to circle the Earth. Getting a person into orbit and back down again safely was an epic milestone, but now the president had just very publicly set NASA an unfathomable goal of landing on the moon before the end of the 1960s. The difference in complexity between reaching low Earth orbit and reaching the moon is difficult to comprehend. These two flight plans are not in the same league. They are barely even the same sport. It took the space agency 7 years of frantic, unyielding hard work and an absolutely humongous sum of money to deliver on Kennedy's promise. But the journey to the moon was so taxing on both the space agency and the nation that after just a handful of missions, the decision was made to pack in the Apollo program and never even attempt this flight path again until the science and technology was truly ready. And now, in the second decade of the 21st century, we are finally ready. So, let's go to the moon. This is the space race. It's a little hard to grapple with the fact that it's been 5 decades since the Apollo program, and we are currently struggling just to retrace the path to the moon that they laid out. It's both a tribute to the ingenuity of those early pioneers and an indictment of how janked up our modern society really is. Either way, we know that Artemis II is looking to be in good shape to mark humanity's return to lunar orbit sometime within the next couple of years. A crew of 4 people will be the first to visit cislunar space in the 21st century. They include Christina Hammock-Cook, the first woman to visit the moon, Victor Glover, the first person of color on a lunar mission, and our boy Jeremy Hansen, the first Canadian to go beyond low Earth orbit. They'll be led by mission commander Reed Wiseman. This mission will be following in the footsteps of Apollo 8, which shared the same basic objective: send a crew out to circle the moon and come home safely. Apollo 8 is a bit of an unsung hero of human spaceflight. Taking place over Christmas in 1968, the crew lifted off in their Saturn V rocket on December 21st and returned on December 27th. The 3-man crew became the first human beings to truly depart the Earth, the first eyes to ever look back and witness the whole Earth from a distance. The entirety of human history rendered so small that they could cover it over with their thumb. If you go through interviews with the Apollo 8 crew, they don't talk as much about the experience of seeing the moon up close as they do about looking back to the Earth. It was a deeply spiritual experience for the 3 men who spent Christmas Eve in orbit around the moon, broadcasting live to the people of the Earth and reading Bible verses from the book of Genesis. It was a fitting end to a tumultuous and violent year in American history that saw the major escalation of the conflict in Vietnam, along with the assassination of both Martin Luther King Jr. and Robert Kennedy. In many ways, the first journey to the moon acted as a unifying event to pull Western society back from the brink. Anyway, not to get too dramatic, I just want to set the stage that there is more to this thing than just flying through space in a rocket ship. This is a big deal. When we go to the moon, we transcend the human condition. We go beyond our status as the people of the Earth. We become the travelers of the solar system. Now, let's get into the logistics of flying through space in a rocket ship. Artemis 2 is going to go sailing past every single human spaceflight that's been launched since Apollo 17 in 1972. A translunar injection orbit makes a trip to the ISS look like a day at the beach by comparison. The standard operating procedure for getting people into space these days is to use the SpaceX Crew Dragon capsule on top of a Falcon 9 rocket booster. The Falcon 9 will lift off with around 1.7 million pounds of thrust, and the second stage engine will raise the crew capsule to meet the International Space Station at an altitude of around 260 miles above the Earth. For an Artemis launch, the SLS rocket will be generating 8.8 million pounds of thrust at liftoff, about 15% more power than the Apollo program's original Saturn V rocket. You can't get to the moon without a spectacularly powerful rocket booster because we are dealing with both a very heavy payload in the 22-ton Orion spacecraft and a very high altitude orbital trajectory. Weighing in at 5.75 million pounds at liftoff, the SLS is going to climb 500 vertical feet in about 7 seconds. This massive acceleration is going to continue for the next 2 minutes until the solid rocket boosters have given up all of their thrust and separated from the sides of the SLS. From there, the core stage with its liquid hydrogen-powered RS-25 engines will burn for another 6 minutes to clear the upper atmosphere and reach orbital velocity. Nearing 8 minutes into the flight, the service module fairings will separate along with the launch abort system, so the little pointy bit at the top and the covers over the capsule will be gone, and now the crew will get their first real view of outer space. Shortly after that, they experience a massive jolt as the main engines cut off and the booster core separates from the upper stage. The Orion spacecraft is going to coast through the atmosphere as the solar panel array deploys itself and the crew prepares for the first burn of the interim cryogenic propulsion stage. They'll perform one burn to raise the perigee of the spacecraft, which is its lowest point in the orbital path, and then a second burn to raise the apogee, which is the highest point in their orbital path. And that will take the crew as far as 1,600 miles above the Earth. They are now about 7 times further away from the surface than the ISS. Once settled into this orbit, the crew is going to remain there for another full day, doing a front-to-back systems check of the Orion. Everything from life support and habitation systems down to the exercise equipment has to be in perfect working order before they are clear to proceed. During the systems check, the Orion will separate from the interim cryogenic propulsion stage, and the crew will practice maneuvering their spacecraft manually using the thruster controls. Once everything is confirmed to be in good order, the Orion can use its main engine to perform the translunar injection burn. It's now 2 days into the mission, and the reason that crew has spent so long doing systems checks is because they are about to pass a point of no return. If anything goes wrong after they commit to the moon, they can't just turn around and come back, and no one can go out to help them. The translunar injection burn breaks them free of the Earth's gravity and sends them on what's called a free return trajectory. So they are going to enter lunar orbit in a wide loop that will slingshot them around the moon and send the craft back towards the Earth. Their ETA to the moon from here is about 4 days. It's a much less direct route than what we've taken in the past, and they won't actually circle closely around the moon. They'll just fly out around it and then head back home. Their apogee around the moon will take them about 6,500 miles beyond the lunar surface into deep space. It's a very similar flight plan to what was experienced by Apollo 13. They didn't do it on purpose. That crew had to improvise a return trip that would get their dying spacecraft back to the Earth before it ran out of power. They ended up discovering a very efficient path around the moon, though. The experience inside Orion is going to be a massive upgrade from the old Apollo days. Not only is the computer system on Orion about 20,000 times faster than the 1960s technology, at 315 cubic feet, there is about 30% more volume than the Apollo capsule. There is a private toilet that pretty closely resembles an airplane bathroom, even a miniature gym with a rowing machine to maintain crew fitness. NASA still hasn't decided if the flight duration of Artemis 2 will be 10 days or 3 weeks. 21 days is the longest period that the Orion can sustain a crew of 4. and NASA wants to be in space as long as possible to give the Orion vehicle the most thorough shakedown cruise possible. The data collected from Artemis 2 will directly influence how they go about the Artemis 3 landing mission and beyond. We can't really say much about what Artemis 3 will look like until NASA spends months analyzing flight data from Artemis 2. As Orion comes around the moon, the main engine will perform a final big burn for the trans-Earth injection maneuver. From here, it's another 4-day travel time back home. The last leg of the trip is going to be the roughest. When the Crew Dragon returns from the ISS, it comes in at a velocity of about 17,000 miles per hour. That's not slow, but Orion will be coming down from a much higher altitude, and that means it is carrying a lot more speed, up to 25,000 miles per hour when it hits the atmosphere. The return window for a lunar capsule gives you about 2 degrees margin for error. Come in too high and the capsule skips off into space, come in too low and it burns up completely. It sounds impossible, but rocket scientists know what they're doing. Even the badly crippled Apollo 13 was able to hit the target dead on. The heat on the outside of the capsule is going to reach around 5,000 degrees Fahrenheit, about 66% hotter than what the Crew Dragon experiences on a return from the ISS. But the climate inside Orion will remain comfortable between 70 and 80 degrees. From there, once all of the ionized plasma burns off, it's just smooth sailing down on 11 parachutes into the Pacific Ocean. So there you go. That's a journey to the moon, a 1,000,000-mile pilgrimage that has not been made in over 50 years. And it's about to happen again in our generation. And just like the Apollo 8 before, Artemis 2 is going to arrive at a turbulent time in our history. Things have been kind of going off the rails around here lately if you haven't noticed. So here's hoping that wonder of human spaceflight can help bring us together again, even if it's just for a short time. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long form